Okay, if you look through a data book, you'll see there is tables with pages and pages of compounds with this value here, delta HF, and the little standard sign there. Okay, what does that mean? Well, it's the enthalpy change of formation. It's really useful, and it's defined in this red box here. So enthalpy change occurring when 1 mole of a substance is formed from its elements in their standard states, and then under standard conditions 298 Kelvin and so forth. Yep. Okay, so let's think about this, the delta HF for methane. That would be carbon, which is solid. And if you're worrying that actually this the standard state of carbon is actually defined as being graphite, not diamond. And then hydrogen, well, hydrogen in its standard state is H2, and 2 of those. And we are going to get CH4 gas. And if you look at the value for that, delta HF for methane, I'll look in my book now, is minus 75 kilojoules per mole. Now that reaction, you cannot find that directly, can you? That's pretty obvious. You cannot get carbon to react with hydrogen to form methane under a copper can and measure it. So you've got to find that by a Hess's Law method. Okay, but we're not talking about how to find it today. We're talking about how useful it is. But if you did want to find it, you'd probably do combustion products down here. You do CO2 and 2H2O. In that arrow there, you burn 1 mole of methane. That arrow there, you burn 1 mole of carbon, 2 moles of hydrogen, and you can find out delta H. But we're not really interested in that today. We're interested in how useful these values are. They're very useful because it enables you to calculate the enthalpy change for almost any chemical reaction. So let's think about this reaction here, which is on the A-level syllabus. You may have come across it. It's actually just about on the GCSE syllabus as well. So when you get ethene and you react it with water to form ethanol. All right, ethanol like that. Okay, and we want to find out delta H for this reaction. They don't give us delta H combustion data this time. This time they're going to give us delta H formation data. I'll write it down here. Move over a little bit if I can. Yep, delta HF. So the 3 compounds we need to know for water, for ethene, and for ethanol. Water is minus 286 kilojoules per mole. Ethene is plus 52, so that's endothermic. That's interesting. So if you think about, if you've started your organic chemistry yet, it's not that stable ethene because it's got that double bond in it where all the electrons are all squashed in there. 4 electrons squashed into a small space. It's not that stable. And then we've got ethanol, which is that's exothermic, minus 271 kilojoules per mole. So now, normally, if we were doing, if we were given delta HC data, what we'd put down here is we put down the combustion products, wouldn't we? As our third thing. We'd put down CO2 and H2O, but we're not given delta HC data. We're given this delta HF standard data. So what the thing we write down there, you might be able to guess, but we put down the elements in the standard states. Okay, what are the elements in their standard states? Well, we've got 2 carbon atoms, solid. We've got 6 hydrogen atoms, so that's 3H2 gas. And we've got 1 oxygen atom, so that's going to be a half O2. I'll put a box around that. Now, which way are we going to put our arrows? Well, delta HF formation is when you form the compounds from the elements. So we're going to go up from the elements instead of say up to the compounds. So the arrows go up in this energy cycle. And the other one, they went down, but just Don't remember that by rote, just remember, think about it logically. Why are these going up? You're forming the compounds. Right, let's have a look at this left-hand side. First of all, we're forming 1 mole of ethene, which is plus 52 kilojoules, and we're forming 1 mole of ethane, sorry, 1 mole of water, which is minus 286. And that is just about within my limits of mental arithmetic. I think that is 234. No, it's not. It's not within my, I'm going to have to do it in a calculator. I'm talking rubbish. Right. Oh, it was 234. I was right. Should have trusted myself. So that's minus 234 kilojoules. That's the number there. Right, this one is easier. We're just forming 1 mole of ethanol. That's minus 271. Now I usually do that in purple, so I'll do that. That's minus 271. So Hess's law, we need to find out the red delta H, don't we? So we want to go that way. Now the yellow, we're going against the arrow, so we do need to change the sign there. And then we need to go up to there, and we're sticking with the sign so we don't change it there. So we write down delta H, the red delta H we're trying to find out, is equal to, it's plus 234. We're having to change the sign there. Stick with the sign, minus 271. So that is going to be negative, slightly exothermic, that reaction. Plus 37 kilojoules per mole. Sorry, minus 37 kilojoules per mole. That seems a bit small to me. But okay, so that's how we use delta HF in an energy cycle. Instead of using delta HC, we can use delta HF. Now I'm just going to summarize the differences between those two things in this last bit here. So I'm just going to call it reactants and products, okay? So we've got reactants going to products. Now this is if we're given delta HC data. So I'll just rub this out. This one is the cycle you use if you're given delta HC data given. And here we're going to do it if you would use delta HF data given. Right, now in Hess's law, we've got to draw a cycle. You've always got to draw a third thing down here. Okay, and it's thinking, what is that third thing? That's the tricky bit. Now, when you're given delta HC, you would have delta HC, you put down the combustion products. Which are usually CO2 and H2O. And which way do our arrows go? Well, when we combust something, you turn it into the combustion products. You don't turn the combustion products into that, so that would be wrong. That's not the way the arrow goes. The arrow's got to go that way. We're turning the reactants into combustion products, so it goes that way. And if we wanted to find out delta H here, this is what we're trying to find out for the reaction, then we'd have to go around that way. So we're sticking with this arrow, and that arrow we're going against, so we flip the sign for that one. If you can given delta HF data, you've got to think, well, what's the third thing we have in our cycle there? We have elements in the standard state. And which way is the arrow going to go there? Well, formation, you form the substances from the elements, they go up. So if we're finding delta H there, we've got to go like this. Well, for this first one, okay, we have to change the sign because we're going against the arrow. On this one, we're sticking with the arrow, so we leave the sign the same. So those, always have a look. What data you're given. If you're given delta HC data, you use this one. If you're given delta HF data, you use that energy cycle. And a final reminder, I wouldn't try and think, oh, they're easy, I'll do it in my head without drawing an energy cycle, because you usually end up getting it wrong. And then it's very difficult to get any intermediate marks for working out if you've just done it all as a string of numbers down on a piece of paper. Okay, leave it there.